Okay, the first step is developing Starship capability to go to orbit. Second step is developing the capability to refuel them on orbit so they can go beyond low Earth orbit. If you can't do that, you can still use them just as a fully reusable heavy lift launch vehicle and proceed with the rest of the mission in a more conventional fashion, for example, with a plan like the Mars Direct plan that I first laid out in 1990. And this is my book, The Case for Mars. Where you use a heavy lift vehicle to get things to orbit, and then the spacecrafts go further from there. Okay, so instead of doing staging, Musk is doing refueling. Now, so you do the refueling. If you can do the refueling, then the Starships can fly all the way to Mars. And you don't need a specialized lander or aerobrake or anything. Starship's got it all. You land, say, 3 Starships on Mars, okay, including delivering a very heavy power system, and by heavy, I mean powerful power system. I mean, you could bring 7 football fields of solar panels if you like, but it's less reliable power on Mars because of the dust storms. You really, it'd be preferable to have a nuke, or several nukes. And then you've got housing and you've got machinery for making propellant. You land, a battalion of robots on Mars. Some of them are exploration robots that fanning out, doing science and prospecting. Others of them are construction robots or work robots that, I mean, if you do bring solar panels, they're deploying these fields of solar panels and plugging them up, that, or they could be mining ice. We've now, using ground penetrating radar, have detected nearly pure water ice glaciers as far south on Mars as 38 degrees north, which is the latitude of Athens on Earth, or San Francisco. So if you have your base near one of those, you could be mining water, and you basically set up the propellant making apparatus. And in fact, the Starships that you've landed, their propellant tanks could be your tank farm. You could use those once they've landed as your storage tanks. You make lots of propellant on Mars. And so before you send your people, you've got a gas station built on Mars. And this is the key thing, okay? In Mars Direct, I sent an Earth return vehicle with a rather small propellant making plant built into its landing stage that would just pump the propellant right up into it. Here, you're basically landing a whole base in advance, and you set up a significant operation to produce propellant on a large scale. Musk's argument for using Starship as a return vehicle is, well, it's okay to use it as a return vehicle because it can deliver so much payload that I can set up propellant making on the scale required to refuel a Starship. I still think it'd be better to have a large payload delivery capability, but have a smaller propellant requirement for the return. Anyway, doesn't matter. This is how it's going to be. We're landing in Normandy, and that's where the war is going to be won. Okay, Brittany might have been a better idea, but that's not where we're landing. And so now you've got a pre-established base on Mars. You've got housing, you've got propellant making, you've got propellant. They maybe even set up greenhouses and are growing plants. So you've got the farm built before the people arrive. It's all there. So all they have to do is check in, bring a credit card, and the food is there, the propellant is there, the house is there. Okay, so that's what you do. And doing it this way, by the way, will, first of all, obviously exercise the whole Starship launch, refueling, interplanetary transfer, and entry and descent and landing on Mars, all that stuff. You could be running the life support system in these Starships on Mars under Martian conditions, even though there's no people in it. In other words, you're retiring all sorts of risk from the program before you're sending people. And then, so you've got this whole thing there. And so now the surface of Mars is the second safest place in the solar system. After the surface of Earth. Okay, parts of Earth. Anyway, so then you send a starship to Mars with people in it, and you're going not to, the housing is there, the resources are there. There's, 50 robots, there's 3 megawatts of installed power there, everything you need, it's all there. And so, if we have starships flying to orbit in a fully operational sense by, say, 2024, and if they can refuel things, the first Starship test flight to Mars could be in 2026. And then several more in 2028. Yeah, land on Mars in 2030 with people.
And then what's the plan for ramp up after that? So I'm guessing the first people will be NASA astronauts, but then afterwards?
Well, here's the thing. Okay. There's one part of Musk's plan, as he has presented it, that I think he will eventually diverge from as he comes to understand the nature of the problem a bit better. Okay, because he's been very focused on the transportation system and hasn't been thinking about the colonization process that much. Okay, we don't just, once we go there, start sending 1,000 starships a year to Mars and bringing in 100,000 people. Okay, okay, this isn't Normandy Beach. It is different. Okay, this is Plymouth Rock. Okay, and so the first mission, well, okay, maybe 10 people.
Mm-hmm.
And
the plan to return.
And the first crew may very well be planning to return. And maybe the second crew is a round-trip exploration mission. But while they're there, they're not just exploring, they're building up the production capabilities of the system. Now you have not just robots on Mars, you got people to help them and organize and this thing. We want to be building lots of greenhouses on Mars. We want to be establishing facilities on Mars that can make steel out of Martian iron oxide. The planet's red because of iron oxide, and steel is a natural to make on Mars.
Are there any materials that you will always have to truck from Earth to Mars, or do they have the chemistry to make more or less everything we need?
The chemistry is all there. The issue is the technology to turn those materials into resources. There's no such thing as a natural resource anywhere. Okay, there's only natural raw materials. It is human inventiveness, technology, that turns materials into resources. Land was not a resource on Earth until we invented agriculture. Okay, oil was not a resource until we invented oil drilling, refining, and machines that could run on the kind of product that it produced. Uranium wasn't a resource till we developed nuclear power. Deuterium is not a resource now, it will be once we develop fusion power. Now, Mars, okay, there's all that red iron oxide all over the surface. That'll be steel or it'll be a resource for making steel when we have the entire soup to nuts technology for making steel out of that under Martian conditions. Okay, there's water and CO2 on Mars, but we have to create automated greenhouses that can grow food using that, maintaining the right temperatures, the right pressures, the right everything. We may be able to take advantage of ambient CO2 to have higher levels of CO2 in those greenhouses than is normal on Earth, because...
Have we done this on Earth? Have we had test runs of completely
Yes, it works. Yeah. In fact, we're doing a global experiment in this respect right now, as you may have heard. And in fact, as a result of the CO2 addition to the Earth's atmosphere, since 1985, rates of plant growth on Earth have increased by 15%. Now, actually, it's a two-sided thing, because the ocean has not shown a similar pickup, because the limiting ingredient for plant growth, phytoplankton growth in the ocean isn't CO2, it's trace elements like iron. If you want to take up CO2 from the atmosphere, if you're concerned about global warming, for example, one very productive strategy would be to fertilize the open ocean, which would vastly expand fish stocks and take CO2 out of the atmosphere in that process. But in any case, on land, it has been a very positive effect. But to get back to the subject, well, greenhouse farmers have for some time, many of them used CO2 enrichment inside the greenhouses, and it does result in increased production. On Mars, we certainly might take advantage of this because you've got lots of CO, you don't have to buy the CO2 for $300 a ton. It's right there. And but in any case, we want to create production capability. And as you create production capability, it becomes logistically easier and easier to support larger groups of people on Mars. Okay, you know, if the first thing, of course, we're going to make on Mars is propellant. We'll also extract water. After propellant, water is the main consumable. Then food. Water is more important than food from a mass transport capability. You use a lot more water than the amount of food you eat. A kilogram of food a day, you use a lot more water than that. Because water is used not just for drinking, but for washing and cooking and all sorts of stuff, and even chemical processes and everything. But so first propellant, then water, then food. Okay, oxygen, of course. Oxygen can be produced as a byproduct of growing food, but it also can be produced by physical chemical means separate from growing food. But then when you go beyond that, you say, okay, what about materials? Okay, bricks, concretes, ceramics, metals, plastics, glass, okay, all this kind of stuff, and then methods for fabricating these materials into useful things. Now you can cast metals, but you can also 3D print them, and then you don't need such a big machine shop capability. Well, plastics are easy to 3D print, and then glass. See, if you can make these heavy things on Mars, relatively crude things, but necessary and involving a lot of weight, this will reduce, you know, by a couple of orders of magnitude the amount of mass that needs to be transported to Mars to support a person on Mars. So now you're just sending, you know, things like, you know, this, iPhones to Mars. I mean, in other words, you build greenhouses on Mars. Okay, it'd be good if the bulk material, the glass or the plastic that composes the bulk of the greenhouse is made on Mars. Perhaps you can even make the motors for the fans on Mars, but maybe the computers that control the motors and the fans, that stuff has to be made on Earth. But you can see eliminating the glass, then eliminating the motors and fans, and then finally eliminating the digital technology. But that's the lowest priority because it's the least mass. Mm-hmm. And it's also the most complex, involving a very complex process to make, and large division of labor. So the big, massive, crude things first, then the medium complexity things, and then finally the most sophisticated stuff.
One of the things I wonder about is, you know, assuming we can get the technology side of things sorted, you know, with the Apollo program, after the first landing, people sort of stopped. They lost interest in the program pretty quickly. And one thing I would worry about is, you know, you have your first landing on Mars, everyone's glued to the screen, there's a lot of excitement. But then as excitement sort of dies down, which may happen again, what's the economic model that keeps the assuming you've got the technology side fixed, what's the commodity that the colony runs off?
Inventions, intellectual property. There are things that you could think of that you might export from Mars. Deuterium is 6 times as common on Mars as it is on Earth, so forth. But really, interplanetary transport of material goods is unattractive. Interplanetary transport of intellectual property, on the other hand, is no problem whatsoever. And the, and of course, the most valuable piece of intellectual property that there is a patent, an invention. Now, I think that a Mars colony is going to be a massive engine for invention, because you're going to have a group of extremely technically adept people and extremely dedicated people, okay, who are in a frontier environment where they're going to be confronted with all sorts of challenges. They're going to be forced to innovate. And also they're going to, for practical reasons, they're going to be relatively free to innovate. And so they will want ultra productive crops for those greenhouses. And they're not going to let anybody tell them that, these extra large tomatoes you're growing could be a threat to the biosphere. It's just bullshit. Okay, we're going to go with this. And then, so genetic engineering, I think, will advance very forcefully on Mars.
So the picture is the colony sort of like an R&D wing of a large corporation in some sense.
Well, yeah, it's an inventor's colony. But you say, well, why not establish an inventor's colony in
the Arctic,
the Arctic or Nevada or the California Central Coast? Okay, well, the reason is the zeal of the people involved. I mean, if you take 3 of the most remarkable colonization efforts of the past 400 years, the Pilgrims going to Massachusetts, the Mormons going to Utah, the Jews going to Palestine, all actually very counterintuitive things. Now, there's some number of things they all had in common. Number 1, the motive was not commercial, it was transcendent. 2, they all had strong home front organizations supporting it based on the belief that it was important. Okay. And who would pay the transport of the actual colonists. And this is actually still true with Israel to this day, actually. But they also had people with, you might say, a lot of steel in their backs because they had this transcendent purpose. And they all produced very remarkable results. And I think, a Mars colony, in other words, you take people, you recruit people who want to go to Mars. Okay. First of all, you'll have no problem recruiting people. Okay. Second of all, you'll have no problem recruiting people that include people with outstanding technical credentials. Well, you establish an inventors colony in the California Central Coast, you'll have no problem recruiting people with technical credentials too. But, they get a better job offer from Xerox, goodbye. And they're not faced with the same challenge. They haven't made the same commitment. They aren't as committed. And so I think the Mars colony, and then also, of course, they will not be as far away from terrestrial regulation. This flu vaccine, The flu, COVID.
Yeah.
Okay. Do you know Moderna actually developed their vaccine in 2 days in January 2020?
But the testing.
That's right. Okay. And safety testing was done by July. And then all the testing since then has been to prove to the satisfaction of various regulators that it was effective on a statistical basis.
That is important, though.
Is it?
I mean, there've been large scale.
Well, wait. No. You're conflating safety testing with effectiveness testing.
No, what I was going to say is there have been examples where there's been medical mistakes that have had disastrous consequences. So, for example, medication given to pregnant women that makes
that's safety testing.
Okay.
Okay. The problem with thalidomide was not that it was ineffective. Let's say it was that it was unsafe. Okay. See, safety testing can be done very quickly. You give the drug to 1,000 people, and if nobody develops bad effects, it's safe. Proving a preventive medicine like a vaccine is effective requires having a group of people be vaccinated and a control population and waiting a long enough time that you can get statistics that these people, that 100 of these people should have gotten sick, but they haven't.
So your argument is that you can innovate much quicker in the colonies than you might do here on Earth.
Well, yes, you can. And
there's no regulatory body.
That's right. And I think they'll be able to innovate much quicker, but both in medical areas and in other areas of biotechnology.
In the long term, is there a chance that the colony might also become a fuel station? I mean, it's a much smaller gravity well to lift fuel up into orbit from Mars.
Well, it could do that, but that's later. That's when asteroid mining becomes a thing, and then you become a logistical support for that. But look, one thing that's characteristic of a frontier is a labor shortage. This was characteristic of the American frontier. And this is why you had a tremendous drive for creation of labor-saving machinery. And, well, fine. And the Martians will certainly go for labor-saving machinery. But now this is the 21st century, and labor-saving machinery includes not only automated production systems, but robotics and artificial intelligence. And artificial intelligence is labor-saving in the sense that you can give individuals additional sets of skills. So it's not just expanding the volume of labor, it's expanding the diversity of the skill sets that are available. And I think the Martians are going to take the point on this. And of course, there's going to be resistance to this on Earth because labor-saving machinery, by definition, puts people out of work in certain professions.
Do you think we're going to call them the Martians?
What else would you call someone who lives on Earth?
I'm looking forward to that day. I guess. Yeah. Oh, just go on, sorry.
Well, anyway, so innovations in genetic engineering, labor-saving machinery, robotics, artificial intelligence, and I think also possibly energy. Okay, what is holding back fusion power on Earth is, well, why not use a waterfall or natural gas or a solar panel or coal? There's lots of ways to make energy on Earth.
I see.
Here you have a novel environment. Deuterium is quite plentiful. But solar power is only 40% as strong as on Earth, and no waterfalls until after we terraform the planet. And fossil fuels, you can make them, but it requires energy to make it. It's a net loss, which is not to say you shouldn't do it because you want portable power, but it's not a net producer of energy.
So you need to innovate just to survive. That's the baseline, essentially.